You guys have this packet? Please review packet. Okay, so with number two, uh, linear approximation, it's really just taking a concept that you already understand and just inserting a decimal into it. So first thing we want to do is gather enough information to get our order pair. And then we get our slope from our derivative, and then we build point slope form. That's really the bulk of the problem. Can you write the equation of tangent line? And once you do that, then whatever decimal they give you, insert that in, and that's your linear approximation. So we're using a line to approximate a value on the curve. Okay, so we plug 2 into the function to get our y value, which I got 8. F prime will get you your slope formula. Plug 2 into the derivative function. That'll give you your slope. Take your order pair and your slope, get into point slope form, and then you do have to make a slight adjustment. Try to get that y by itself. Once that y is by itself, then the decimal gets inserted into the x. Whatever you get as a result, you're using the line to approximate a value on a curve. And you can use your calculator for that. Okay. Any question with part A? Okay, try part B. Part B should be even easier because you don't have to find the slope or the order pair. They give all that to you. Just put it into point slope form, and then the decimal gets inserted for x again. Okay, try part B. Okay, no questions, linear approximation. All right, next up, L'Hopital's rule. So it's just finding limits. Remember, not every problem, not every limit problem can we apply L'Hopital's rule. We always want to do direct substitution first, right? So do direct substitution, and then you see what you get in return. There's only three options. Either you get a real number, which means it's continuous. If it's continuous, that means there's nothing more to do. After direct substitution, if you get a real number, you stop. That's your limit. If you do direct substitution, if you get 0/0, then that tells you that there's a hole, and that gives you the green light to do L'Hopital's. So L'Hopital's is take the derivative of the top, take the derivative of the bottom, and then reevaluate again and see if that will get you to a real number. And then the last option is if you do direct substitution, if it gets you 10/0 or 8/0, then that means there's a vertical asymptote, and then the limit doesn't exist. So direct substitution first, and yeah, see what you get. Try A and B. So for 3A, direct substitution got me to a real number. So I don't do L'Hopital's rule. I don't do anything. That's my answer. That's my limit. Try part B. Okay, so direct substitution, we get 0/0. That tells us that we can do L'Hopital's rule. So derivative of the top, separately, derivative of the bottom. Once you take the derivative once, you stop and you do direct substitution. We don't want to keep finding derivative over and over again. As soon as we do L'Hopital's rule, we do direct substitution again and see where that leads us. If that leads us to a real number, then great, we can stop. But if we get another 0/0, then we can do L'Hopital's rule a second time. All right, any questions here? Okay, moving on to number 4. Water is leaking out of a cylindrical container at a rate of 5 cubic centimeters per hour. The container has a diameter of 12 centimeters and height of 16. At what rate is the height changing when the water level has a height of 3 centimeters? So this is not a cone, this is a cylinder. And we know that cylinders have a different process and it's easier, right? What is it about cylinders that makes this easier than cones? The radius is constant. So a couple of things to watch out for is you may have some extraneous information, meaning that there's data that would be good for cones, for setting up similar triangles, but not necessarily needed for cylinders, but you still have it. So just make sure you know what information you need and what information you can do without. Because sometimes we look at all this data and we feel like, oh, I got to use it all. So I'm going to go ahead and start using similar triangles. But there is no triangle shape with cylinders. And we have to keep in mind, it's an easier process. You may have some extraneous information. Okay, so here's my volume formula. V equals pi r squared h. What is the radius that we can replace? Diameter is 12, therefore radius is what? 6, yeah. So we can go ahead and replace 6 in for r. There's no need to hold on to that, right? Because we know that, as the water level is dropping, this radius is staying constant the whole time through, right? It's not like cones where your radius of your cone is going to either shrink or rise depending on what's happening to the water level. Here, your radius is never changing. It's going to stay 6 centimeters throughout the entirety of the problem, right? Okay. And as soon as we replace r in for, or 6 in for r, we can move directly into our derivative process. We don't have to wait and do similar triangles and do a whole bunch of substitution like we do with cones. Okay, so it should feel a different but easier process than in cones. Okay, let's go ahead and find our derivative. V becomes dv dt. Okay, you guys try it. See if you guys can finish this problem on your own. So the rest of my derivative, 36 pi, will stay, and my derivative of h becomes dh dt. Let's see what we have here. We know dv dt is -5. Water is leaking out. At what rate is the height changing? We're looking for dh dt. But they gave us all this information that we don't need, right? They gave us the height of the water level, which we don't need, right? We already found the derivative. The h already disappeared. And they also gave us the height of the container, which we also don't need as well, right? All we needed was dv dt, which was -5, and that's enough for us to solve for dh dt. So, but if you get distracted by these numbers, you may feel like you may start going down the road of doing similar triangles because you feel like you got to reuse those data somehow. But These are distractors, good for cones, but not necessarily needed for cylinders. Okay, divide both sides by 36 pi. Pi stays in the denominator. And then our unit of measure is height is one dimensional, so just centimeters per hour. Okay, page 6, back to a Pythagorean theorem problem. Okay, a boat is being pulled toward a dock where there's a rope that is being hauled in at a rate of 2 feet per second. So here we have the dock, the boat is here, the rope is the one that's getting pulled. And this distance is not changing. We know X is changing, we know Z is changing, but Y is staying constant. So the boat is getting drawn in closer towards the dock and the rope is pulling the boat. So that's the scenario. Go ahead and set up your Pythagorean theorem. Go ahead and find your derivative and see if you can list out your 6 variables and start assigning values to variables. See how well you guys can do now that we've done a couple of these. Okay, go ahead and find the derivative. Right, 2x dx dt, 2y dy dt, 2z dc dt. So we know the dock is 6 feet above the water level. Z is the rope. So there's 10 feet of rope out. Pythagorean theorem, we can work backwards and figure out what X value is at that moment in time. We know dy dt is 0 because that distance from the water level to the top of the dock is never going to change as time passes. dc dt is -2 because they say that the rope is being hauled in at a rate of 2 feet per second, but as it's getting hauled in, we expect this rope to be decreasing in length as the boat gets closer. So we know dc dt will have to be a -2. Now that we have 5 out of the 6 variables accounted for, we can plug into our derivative equation and then solve for dx dt. Which should also come out as negative because if if the boat is getting drawn closer towards the dock, then we expect that distance, this distance from the boat to the bottom of the dock should be decreasing, right? dx dt should be a negative. Okay, part B. At what rate is the area of the triangle changing? So area's formula is area of a triangle is 1/2 base times height, 1/2 xy. So if I want to find the rate of change of area, I have to find dA dt. But to find dA dt, with 2 variables here, what do we have to go through to find the derivative? Product rule, right? I can't just quite say 1/2 dx dt times dy dt. So and technically, I guess we could replace y with 6 since y is never changing. But let's just go through product rule just so that we get that practice in, because it's not every circumstance that we can expect both the x and y to be constants. But technically, we could avoid product rule, but let's just do the full practice for product rule. And then we can use the data from part A to fill in all those values for variables. Okay, try that. F prime g plus fg prime. Okay. Once we have a derivative spelled out, then the rest is easy because all the data you can just pull from part A. And then finally, units of measure. Area is 2-dimensional unit, so area is square feet. Time is seconds, so we just put those units over each other, square feet per second. Okay, any questions? Okay, so we're gonna do a cone problem every day. So let's try number 7, see if we can get that whole set up. Okay, so with cone problems, we know we're always having to set up that proportion equation. Small radius is a big radius, as small height is big height. And remember, there's always going to be a number that we have to stay away from. Right? There's always a number that we have to make sure we don't use too early, and that number is 30. This is the height of the water level, which we don't want to use because it's not, the water level is not always staying that value. So we have to hold off on using that value until the very end until we build our derivative. So we're not going to insert that 30 in for H. We have to hold on to our variable a little bit longer. And the next decision that we have to make is, well, how do we know which variables to solve for? Am I solving for R or am I solving for H? And the hint is whatever variable, whatever you're looking for is telling you which variable you want to keep. So if I want to solve for dHdt, I want to keep H, which means I want to get rid of R. If I want to get rid of R, I want to solve for R so that I can find a replacement for R. The big trouble that students typically have on quizzes are after making a substitution, trying to get all the way down to the point where you can find the derivative easily. So I see some students either cleaning up incorrectly or finding the derivative too soon. We have to get rid of all the parentheses. We have to clean up all the variables, get it all nice and clean. We should have just a fractional coefficient and then one variable raised to a power. It should really be as clean as that. If it's any more, any if it's complicated, more complicated than that, we have to keep going. We have to keep cleaning up until you have a relatively easy, nice equation so that your derivative can be an easy process. Okay, so now we can find the derivative. Again, if you start plugging 30 into H, it's too soon, right? You only want to use this moving value at after the derivative. Okay, B becomes dV/dt, coefficient stays, H cubed becomes 3H squared dH dt. And now we can start working the values. dV/dt is -2. You can clean up however way you want to, but eventually that 30 will go in for H. And I'm dividing by that fraction to get that over, which is the same thing as multiplied by the reciprocal. And I get -8 over 2025, and pi stays in the denominator. Any questions? Right, let's go to page 7. So your homework is page 7 and 8, and we'll just try to get through as much as we can. Whatever we don't finish will be your homework. Okay, your homework will just be page 7 and 8. But let's try. Let's see if we can get through a couple of problems before for the next 15 minutes or so. We have volume and surface area of a cube. Go ahead and find each derivative, and then use the data to see if you can make your way down to what they're asking for. Okay, go ahead and find your dV/dt, find your ds dt. Every variable gets impacted by time. So once you find your derivatives and you assign values to variables, we're looking for the SDT. We have surface area, we have dV/dt. So now it's like a little bit of a puzzle here. How can we get to dsdt with the information that they provide for us? It may not be a direct value that we need for dsdt, but it will eventually help us get to what we need, because we need x and dxdt ultimately plug in. So figure out how can my surface area and my dV/dt help me get to these values that I need to plug in. Okay, surface area is 54 square meters. This is helpful because if I put 54 in for S, I can solve for X. If I solve for X, then that's one piece that I need for my dFdt. Next piece, I have dV/dt. I can use my -10, plug in for dV/dt. But once I have my X value, I can plug that in, and that should allow me to get to dxdt, which is the second piece that I need for my ds. So that means this will get us an X value of 3. And then once I replace -10 in for dV/dt and 3 in for X, I can solve for dx/dt, which ends up being -10/27. And then once I have my X value and my dx/dt, I can now solve for ds/dt. Surface area, focus on that second word there. Area is a two-dimensional unit. So square meters. Time is hour, so square meters per hour. Okay, let's see if we can get in one more problem here. So number 9. Number 9 is another Pythagorean theorem problem. I have the diagram drawn for you. So you guys can copy this now. Yeah. You have jet A traveling east from San Francisco towards St. Louis. Jet B is traveling north from New Orleans up to St. Louis. And you see the triangle being formed between jet A, St. Louis, and jet B. Jet B travels north at a certain speed. Find the rate of change of the distance between the two jets. So again, x squared plus y squared equals z squared. Pythagorean theorem, we should be able to get, after we find our derivative, we should be able to get our dx dt, dy dt, and dz dt to show up. Let's talk about the rate of change for each of these. What's going to be, what do you expect out of dx dt here? Positive or negative? What's happening to x? Is this distance getting shorter or longer? Shorter. So therefore dx dt should be what? Negative. Even though it's moving right, we talked about how direction has no bearing on the rate, right? We have to look at to see what is happening to our value. Is our value getting larger or smaller? So dx dt should be negative, right? What about dy dt? What's happening to y as time passes? Decreasing. So dy dt should also be what? Negative, even though it's going north, right? I know that we associate north with positive, but in this case, we can't say that the distance is increasing between them. The distance is decreasing, so dy dt is negative. What do you expect out of dz dt? What's happening to z as time passes? As jet A and jet B gets closer towards St. Louis, what's happening to the z? Decreasing. So we also expect dz dt to be negative as well. Right? So in this case, all the rates are going to be negative because the triangle is closing in, right? So I have the value for x, I have the value for z, I have dx dt and dy dt, but we're making the adjustments by making them negative. And then to find y, I can use Pythagorean theorem, a squared plus b squared equals c squared, working backwards to solve for y. It'll be a decimal value using your calculator, and then the rest is inserting into your calculator and finding dz dt. So our final answer is dz dt is negative 732 miles per hour. So that tells us that that distance between the two jets are decreasing at a rate of 732 miles per hour at that moment when x, y, and z are those distances apart. Okay, so your homework is to finish the rest of pages 7 and 8. I'll send out a reminder this afternoon. Also help sessions this afternoon at 3:30, tomorrow morning at 7:30, and Wednesday morning 7:15. Your quiz is Wednesday, and it's basically going to look like these couple pages. It's gonna have one of each type, and if you're comfortable with each type of related race problem, linear approximation, and one L'Hopital's rule, you should feel pretty good about the quiz. All right, go get your phones. Okay, so I'll mark it down. Thank you.
Also, I was curious, like, I know which day I missed the homework, so I could like show you, like, about take points off,
Yeah, but it's like minor.
but not many points.
It's like you get, every homework is 5 points.
Yeah.
So you get 4 out of 5. It just shows, this shows you get 4 out of 5.
So it's like hard to read. Yeah.
This one here,
Is that
page 24, number 58.
which like they were
Review, I'll go with 53.
Yeah, that is.
Okay, here we go. From the chapter 2, 3. Yeah. Yes. Solid.
I didn't go back and check my notes. Oh, I almost did that. I scared of that. It was like very cool. That's what I can say.